So, hello everyone. Today's session is again another power pack session on language models, is implementation, comparison, challenges in Indian context. We have Harshada Shangarpawar and Gayatri Venkatadar. So both Harshada and Gayatri are partners at AGH Advisors, having 20 plus years of experience. They held leadership positions with global giants, having hands-on expertise in designing AI-driven solutions for myriads of business functional domains. Harshada also holds a prestigious MS in Applied Statistics from IIT Bombay, while Gayatri is a graduate from XIMB. So let's dive into this insightful session with two powerful leaders and speakers. Welcome you, Harshada and Gayatri. Over to you.
Thank you.
You can start. Yeah.
Thank you very much. Thank you, Munmun. And I'll start, and Harshada, I think you can join as we go on. So welcome today. We hope over the next 45 minutes or so to talk about our experience in using language models, specifically, I think, on projects which work on data that is generated in India and for usage by Indian companies. We'll talk just for a couple of minutes about AGH Advisors, who we are and what we do, so that you have some context to where our experience in this space comes from. Harshada and I have been doing this for a few years, so we thought we'll also spend a couple of minutes talking about how we've seen the space of data science evolve over the past 20 years or so. Then we look at the current state of language models which are there and share a few case studies with our experiences on this. Yeah. So like Munmun mentioned, Harshada and I have been running a partnership firm for the past 6 years or so. We both have 20 plus years of experience in the data science space. We've worked across industries, telecom, media, banking, consumer packaged goods. Harshada's worked with pharma and finance and retirement services extensively as well. I have also worked with consulting firms, so I tend to work more on the more in that framework. And Harshada has held leadership positions working with large teams in delivering quality analytics even in high pressure environments. So between the two of us, what we typically do is in our firm, we do what we call analysis sprints, which are quick projects which last about a month or a month and a half, so that some kind of analytics or data science which is done can directly be implemented in a business decision, so that you are able to discover the value of using this inside the business. Because very often, people use large words, but ultimately it succeeds only if it is able to generate revenue or profits when used inside a business. So that's one of the key focus areas that we have. We also work on data science solution design, so that once you know what data you have access to as a business, what is the kind of solution that will best work for you? That's something that we design at a higher level. Those can be implemented through a third-party solution, or sometimes we participate through sprints to take it into the business. We also offer project management services for those who are running larger data science projects to say, how should these projects be managed and to help with the testing of these spaces. We wanted to kind of start off with talking about how the inputs available for data science have become much richer over the past 20 years or so. Harshada, you want to kind of talk through this one?
Yeah, so 20 years span because we have been in the business for 20 years. That's the only thing that was our guideline. So types of data have changed, right? From the time we entered industry where structured data was what we based our analysis models on, we have moved on. 2014 was a bit of hybrid where, instead of old-time oracles, there were newer databases that were coming in picture. There were different types of data coming in picture. Initially, we started with categories and numbers. In 2014, we got to see a little bit more of text coming into the data analysis framework that we were building. 2024, there are a lot of media, artifacts that come into your unstructured data, including PDFs, including text in other format, audio, video. a lot of other things. So data has changed, types of data that we work with. The volume has changed. So 2004 was when customer data that we worked on for a project was, and I'm talking about zettabytes because that's what people are measuring nowadays. To today, when we work with more than 12 plus zettabytes using Colab, which sits on our system essentially, we see the analysis results there versus working on servers, which we started off with in 2004. So volume has expanded and speed of processing. So we had databases, Oracle databases, which used to get updated every month in a campaign context. Every month we ran campaigns versus in 2014 when it was hybrid, you had figured out some of the transactions were more important and needed to be caught. So there was batch plus real time versus now everything is real time. So I get to know what has happened, what actions you have taken, and therefore the campaigns from a direct marketing space have now also become digital marketing driven, where you have Google ads, different models running behind it, which gives you the right thing to target your audience with. So data has definitely evolved over the last 20 years. Moving on.
So, given that the inputs have become richer, what we can do with it has also become richer. Because even if the input pipeline is high, unless the pipeline of being able to analyze it also becomes high, we would not be in the good place that we are today as far as this is concerned. Now, the pipeline available for data management, say in a 2004, like Harshada was saying, was traditional RDBMS. So the skill that was valued was if you could build a good entity relationship diagram and design a database that was, reasonably strong. That was what was valued. By 2014, it was more adaptable. Some intermediaries were available. Cloud-based solutions began to be used, but they were not as fast and as pervasive as they are today. Today, we have real-time data capture and storage of really vast amounts of information and solutions which are cloud native for the data management part as well. Our tools and techniques have also kept up. Previously, we would do custom estimations of statistical models. It would take a long time even to process a small, like a 2 GB, 3 GB data set to be able to estimate a shade or a cart would take an enormous amount of resources. Even in 2014, we were looking at custom estimations of statistical models. BERT, etc., had started to make an appearance, but we were still in a zone where primarily we were using regression models on smaller samples of data, and we were not working really with very large data sets as well as far as the estimation of models was concerned. But now in 2024, we're looking at a really different world where deep learning models are used on a regular basis on very large data sets to be able to provide the results. Right? Programming languages and software with which this work is done, both on the data management side as well as the tools and techniques, have also changed immensely. I'm only including the software which, as front-end analysts, we would use for the statistical modeling part of it. There's an ocean of things out there on the data management side as well, which are not included on this slide. So SAS, R, SPSS, Minitab, some of these you may not have even heard of when you were working on. Those were what got used in 2004, and typically they would be used on a desktop. Sometimes you would get a server installation of it, but certainly, computing capacity was a definite constraint. Right? By 2014, Python had come in. It was much more widely used, and model estimation becomes easier, which is why we began to use, more nonlinear models began to get estimated more frequently in the work that we were doing. Today, we're looking at Python. There is also a huge, push towards using no-code or low-code tools, which have democratized model building. So even without knowing the statistics of it, you can go ahead and start estimating a statistical model and put it to practice in your process today. What we'll do is also talk about the outputs and how their usage has evolved. And we'll look at a couple of case studies for, say, two industries that Harshada and I have worked in. So that should give you an example of, how some of these projects might have looked in the past versus how they look today and what drives this. Incidentally, as we're going through this, if any of you have questions, just feel free to ask during the session itself. I think an interactive session will work better for all of us. Yeah. So we'll just take a couple of minutes to talk about how credit risk for consumer banking might have used analytics in the past versus how it looks today. So, for example, in say 2004, you would get structured data which was collected on a weekly or monthly basis, and this is for consumer accounts. If you were working with commercial banking where data of businesses was collected, that would be like on a quarterly basis sometimes that you would get the data. So you're looking at very, very low dimensionality of data in terms of the number of columns that you're able to actually collect for your analysis, right? Model types would typically be something like a logistic regression, which focused on a linear relationship between the data elements. So, for example, you would say, okay, the debt to income ratio, if it is high, then it means that this particular person is more likely to default on paying his loan. And the relationship would be linear, which means that if his debt to income ratio went up, double, then the likelihood that he's going to default would also go up by the same amount. And this is a more simplistic way of looking at it when it's not really that simple in the real world. How these models would be built, typically you would take 12 to 16 weeks, which is about 2.5 months or so, to estimate the model on data that you had collected. And that model would challenge the existing model, and the replacement would actually happen on an annual basis at best. That is typically what would happen. So one model would get used and monitored for typically 1 year or even more to classify, which customers were risky versus which ones were not. The usage was also very different. Typically, these models would not make automated decisions. It was part of an agent-driven case flow. So if you went to a bank branch or you went to, some underwriter would get a case which said, this is the person's income, this is how, if any of you have applied for a loan, you might be familiar with this, right? Where you're getting a whole bunch of, you fill in a form with all that information. That's what would get fed into the static scorecard. And an agent would say, oh, okay, this person has a high score, so let me accept it. Or this person has a score which I'm not sure of, but based upon my interview with them, I'm still giving them a loan. So the agent was very much in the lead as far as the decision making was concerned, and the model was just an aid to them, right? Whereas by 2014, we were looking at higher dimensional data. Some unstructured data was coming into these models after being converted to structured data. Model types were improving. We were able to model non-linear relationships by using things like random forest and gradient boosting. Real-time inputs were being used, but the regulatory requirements meant that replacement, especially for credit scoring models, was still on an annual basis, and the decision making was more automated. So there were definitely cases, especially for things like credit cards, where pre-approval agents would not make the decision. The score itself was enough to be able to say that the person could be sanctioning the card or not. Okay. Today, what we're looking at, and banking is actually a space where I think the evolution has been less dramatic. We now have the ability to use unstructured real-time data. Deep learning models can be used. However, real-time models are not always used due to regulatory requirements in this area. So, for example, in a credit score, even today, you can't use a deep learning model because you can't have a black box. The regulator will come and ask you, what did you use in your data to decide that this person can be given a loan or cannot be given a loan? And the bank is obliged to give an answer. And if they're using a deep learning model, they can't do it, right? So the usage of these kind of black box models is limited to areas like fraud or AML, where there is a benefit to it and the regulator is also okay with that kind of model being used, but not necessarily in something like credit scoring. So I'll pause here before we go on to the next case we have, of which kind of talks about how the evolution of data science has worked in this space. Any questions specific to this one?
Anyone having any questions, just raise your hand and ask the question. Yeah, I think we can go ahead, Gayatri.
No problem. Harshada, you want to talk about this one?
Yes, so similar view in terms of call center operations. In 2004, these operations were very human intensive and resource intensive. You had X number of agents, and therefore you could take only X number of calls. So infrastructure was limited. You had center agent with some static script, and if something else came up as a question, most of the time there were escalations. The customers didn't get the answer that they wanted. There was a lot of wait time as well because the operations were not streamlined. And analytics used at that time to measure the performance, etc., were very quantitative. How many calls got answered per agent? How many calls were received? What was the call duration? Did it last beyond X threshold? Those were the kind of statistics or measures that were, looked at. Offline analytics was what was done, saying for my portfolio, this is what is working and this is what is not working. And there was obviously a huge lag between when things happened and when strategies got put in place to avoid it in future. So by that time, you can imagine there was a blast of similar complaints and things would have gone to the CXO level. In 2014, as computational uh, pieces increased and people worked on solutions that were IVR specific, you had more options. So there was IVR, not always answered by a human. There were, those items that came up. If you want to inquire for balance, dial one, and then your question would be answered. So the simple ones were tackled. Again, the resource intensiveness remained. Call agents took up more value added pieces that were needed. Calculations and reporting of quantitative metrics continued. So, number of calls taken, how efficient is the call center, etc., remained. But the transcripts were getting increasingly analyzed. So we knew who was talking about what was the greatest problem in your product or in your services. Some piece of text analytics also got into picture. So, I mean, a quick example could be if a call is a complaint and you know when a call is can be categorized as complaints, you can answer it better or have a agent who is accomplished and more experienced handle it. So those type of things started happening. 2024, as large language and generally language models came into picture, a lot of it was now chatbot centered. So even on a even before getting to a call center or even on a call center site, chatbots answer your questions sometimes very smartly. Obviously, they fail because the hallucination part comes in, but a lot of improvements have happened. Conversational AI first is what happens. So they try to close your complaint with AI ML intervention versus getting it on the floor to the agent. A lot of quality controls also started kicking in. Also, call center agents had real-time data access and it was omni-channel. So if I had complained on a particular channel and now I'm calling to your call center, the agent already knew what was the history of where I'm coming from. So LLMs created a lot of chatbots which eased and enhanced customer experience. Voice analytics was getting dynamic. So you could do who said what, diarization, how long was the call, in that call, how much the agent talked versus the customer talked. What were the sentiment, what were the tone. You started measuring that in addition to your quantitative matrix. Readiness to tackle complex multilingual conversation, especially in Indian context, had started kicking in. So what we had noticed is the conversation starts in English, and then the user might be more familiar with a local language like Hindi, Kannada, Marathi. They will slip into that, and that's where the analysis was failing because automatically the algorithm wasn't able to figure out which language is it and therefore take action. So that those problems now had solutions. In process, call quality monitoring was possible. So I could say, how am I going? Am I making sense to the customer, or he is getting more agitated by what I'm saying? Routine customer interactions were obviously off this loop because they were handled more efficiently due to the AI ML pipelines built in. Again, do you want to pause before we move to the other slide, or should we carry on?
Uh, I have a question, Harshada.
Sure.
So, basically, what we like, I have seen, like in my experience, there is lack of like quality annotated data for Indian languages.
Mhm.
Like, have you also faced similar kind of like things?
So yeah, things are evolving. Like I said, Google Translate. There are a lot of tools now available, either standalone tools and also libraries in Python themselves are getting more strengthened. So there is an opportunity of converting your conversation completely into Hindi. If you had to answer, if there was a script for an agent in English, it is now easy to translate it into Hindi and answer a user question. So yes, I mean, things are evolving, and same challenges we did face, but some of it we were able to tackle using some of the solutions that I mentioned. Google Translate being one. Bhashini actually is coming up pretty big, and then there is Sarvam as a platform which does a lot of localization from a language perspective.
Okay, yeah, got it. Yeah.
I think Avijit has raised his hand.
Yes, so I have a question. Is that in this, I mean, recent years, we have been seeing that the AI agents are taking over for the call center part, right? For supporting customers. So, what do you think that isn't it going to be affect the customer sentiment? Because I have seen that many call centers, especially in Google Pay, when we call, it is an automated voice, and I know it's an automated voice. It's a programmed system, and I am giving my complaints. Although the human touch is going to be missing from the future, so wouldn't it like that the customer empathy will be? I mean, you know what the trust is. Somehow the whole interaction process could be a bad impression. What are your views in
Uh,
this case?
Yeah, so there are contradictory views. I think what we should build is more to support a human rather than take away anything from the human. So if your complaint is regular or your query is regular and it gets solved by a agent versus human, I think we are still fine with it. It's also about acclimatization, right? A couple of years back, a lot of people didn't want Siri, or Alexa was new, and there was a bit of scare. Now it is more than it's more annoyment than the scare. That's what remains. So I think our approach should be to help operations versus taking anything away from it. Customer experience will build if the problems are addressed more efficiently. So in past, talking to human, if it was going to take 5 minutes to solve my problem versus today, putting my problem to agent and getting it solved in 2 minutes, I think my appreciation would still increase for what they have built. Again, that's my point of view. Gayatri, anything that you want?
Yeah, so I think what we are talking about in this session is, what is possible, and the range of possibility, like you said, is it's quite large now. I mean, you can choose to get your problem solved by calling and pressing buttons on an IVR. You can type it into a chatbot and get an answer, and you can call, and if you wait long enough, and if you're lucky enough, you can even speak to a real human being and get your answer solved. And now each of us, depending on where we come from, how much time we have, what is our preference for how we would wish to interact with that particular product, are going to have a preference. There are going to be some people who want just to do a text and not talk to a person. And there are going to be some of us who feel that something is incomplete and who feel that it is not a valuable interaction unless I'm talking to another human being who shares, something with me. And I think businesses and the natural law of, so to say, profit will drive how much resources get allocated to each of them, right? I think eventually we will, my own personal point of view is eventually we will hit a critical mass of customers who share a very, very strong preference for interacting with human beings rather than with, chatbots or with conversational AIs. And then there will spring up that particular type of business which will have that as a differentiator. But I think in this session, what we're talking about is the art of the possible. Now, whether it should be done, whether it is going to be profitable to implement it or not, I think that's a second question which has a different set of drivers to make that choice happen. Does that kind of answer your question, Vijay?
Absolutely. Thank you so much for answering the question. Thank you.
Thank you.
Yeah, so I think one thing that we have noticed, and this is why we took you through that entire 20-year process, is that we are also living in a new world. Sometimes I feel like the 15 years of experience that I bring to the space is perhaps more of a handicap than not, because everything is so different. I may as well be a fresher too, because language as an input of analysis has exploded in the past few years. Right? From being a peripheral source of data input, it has now become a centralized source of data. And Harshada can speak to how this looks, for example, in the legal space.
Right. So, I mean, each customer needs a full file, correct? And especially in cases where data is more text driven, one of which being the legal space, where it's more documents that you have to look at, like contracts, court judgments, bare acts. So that's the source of data. And to do any analytics meaningful there, you need to make sure that that is your source of data and how you're going to use it to solve different use cases. So it has definitely become central in a lot of domain space. Multilingual context, we spoke about it earlier. A lot of conversations move seamlessly across languages in call center, right? So that is covering urban location in addition to rural actually requires a lot of local approach. So strong transliteration of documents, and this is true for legal as well. So a lot of district courts, high courts now have their documents in local language, which is much more stronger than the English counterpart. Sometimes English document is just a summary of what happened, versus the local language document is more detailed. And for some cases or for some analysis, you do need to get into the details. So therefore, language is important, and multi-language or multiple languages are important in this context. Also, quantitative data is what we had worked on when things were more linear. We had only couple of models to choose from, a couple of non-complex things to solve for. But as we start solving more complex problems, getting the qualitative data as inputs, including tweets, including other social media inputs, this simply can't be ignored, because I will get just a snapshot of a profile from the structured data. But what else is happening in a company? I will get to know only looking at other with data which might not be quantitative. It will be qualitative. Yeah. So again, shift from a numeric to non-numeric format that we have seen in past. And the supporting capability. So structured database, Oracle 20 years earlier could only support certain length of string or certain characters within it, versus now we have vector databases where a lot of things can be saved, including long text, media, and it can be much more adaptive to anything new that comes in. So yes, there has been an explosion.
And I can't say how much of a difference it makes that actually. So that part about, that previously the work of the analyst or the work of data science or was limited to where the numbers were, right? And so previously we started with a number and ended with a number. What happened to give us the number and what happened with the number we gave so that it could get used inside the business was something that typically happened outside our site. Whereas today, we are able to get access to that data real time. If it's a picture that's being taken, we get to analyze that picture now. And the output that we're giving is also a usable picture. So therefore, the shift for the context in which a data scientist can work from being limited to only working in the numbers to working absolutely that I think is it's a very interesting change. I mean, the work becomes therefore a lot more interesting and also becomes a lot more effective in how often it is used. Okay. We'll dive now into just specifically language tasks and what we think about it. Harshada, you want to just talk to this point of view?
Okay, so this is just one lens that we thought makes sense after doing good amount of projects in this space. And obviously everyone would have a different way of looking at it. I thought we thought this was a good picture to put up in front of you. So there are language tasks when it comes as a business mm, problem to us. So what we have learned is that you need to figure out what kind of task it is based on the length of the text that you get. So there are different models which work in one context and different models which will work in another context. The definition that we have used for short text is, say, less than equal to 500 words, which would be more like a customer complaint or a note that an agent puts in after having a call with a customer, or a tweet that is made, or a short email that comes from a customer. And long text could be books, could be the cases that get put up, hearings that get put up on the court sites. So when you get short text, the kind of use cases that we have seen is to figuring out themes in the short text. An example could be, there is a customer writing to a company, or email in a company. Somebody needs to figure out what is the email about. Is it a complaint? What kind of themes are covered? Or there is a video that is posted by a influencer. What is the content? So you convert the video to text. Text is then analyzed, and you figure out what the sentiment and tone of that particular video, audio, or text is. The second could be classification. So in case of, say, a CPG account, you would want to know what kind of text are you getting. So again, is it a business specific text? Is it email which says that there is a problem with your SDG handling solution or ESG solution? Is it something else? And that could be classified as supervised and non-supervised. By that we mean that the business tells you that these are the categories that you will get text in, and this is the text, therefore classify it, versus unsupervised. So I'm doing an analysis of what text I have got or what messages I have got from, say, the 5,500 messages that were sent to me. How do they fall in different buckets? Which buckets do they come into? In the long text context, so you have, say, a book which is 10,000 pages long. You want a summary, obviously. And most of the time nowadays, you just don't want a text summary, you want an audio summary as well. So you want to hear while you are on the go versus sit and read something. Again, searching stuff, it becomes easier when from a long text, I have some elements extracted. So it could be stakeholders, who am I talking about? It could be timelines, what happened? So what is this document saying about what happened, what event happened at different times, and what were the actions taken or who did what. There could be an outcome. So outcome is actually a special case of element extraction. In case of judgments, or in case of complaints, the trail of messages that get sent, was the complaint resolved or is it still open? That could be an outcome. In case of judgments, one who lost could be an outcome. Yeah, I see a hand raised. Nidya, sure, go ahead with your question.
Hello, ma'am. Good evening. Am I audible?
Yes, you are.
Uh, Actually, ma'am, I have a question that is, during these days, we are hearing about a new topic that is very booming known as generative AI in it.
Correct.
Right. So basically, what are the means practical implications of this generative AI? How it can affect the software developer jobs, or it can means either it can affect the software developer jobs or new jobs will you create. What's the impact of it?
Okay, good question. I thought this is a little off scope, but NLG is the interpretation part that we had put on this slide. As Gayatri mentioned during the previous slide, your outcomes are now converted from just numeric to more interpretable, right? That's where Gen AI comes into picture. When you're generating visual, in addition to what is seen, you need a commentary, which is what Gen AI means in this context. But I think we are not here to discuss the job piece. Gayatri, you have any comments on that?
Yeah, so I think the what is certain, the only certainty is that there is going to be change. Um, Everything else of what that change is going to be, what jobs are going to look like even 6 months from now, I don't think the answer is clear. But I think the best thing that all of us can do to adapt, as we work, is to use these tools in our work and see where they take us. There is no ignoring it. So if you're asking about, for example, software developer jobs, certainly it is going to change because generation of code is now you go in and type in, and I'm sure all of you have done this, that you can go in and given a use case and you can get some tool with some code which is not 100%, but it is going to be like 90% there for sure for any task that you want to do, especially for simpler tasks. So has it changed? Yes, it means that therefore as a human being, you're constantly dealing with complexity. And how can you become the person who does that? I think we'll only be able to use the tools, get used to it, and then the answer will be with us. So like Harshada says, it's a little off topic. And the short answer is we don't have an answer either, but we'll all have to stay with it because things are very interesting.
Yeah, also looking at it from a historic perspective a little bit. When we started, there was no designation called a full stack developer. Right now, we see a lot of those jobs coming up. So, I mean, you are expected to know backend, middleware, front end, everything, and people are doing it. So, I think that's how it's going to evolve.
Not to mention, say, prompt engineering.
Prompt
Prompt engineering as an actual task or a space where someone needs to apply intelligence. That did not exist like a year ago, and it exists today. Right. So I think the answer is, are there going to be, I think your question itself had the answer where you said, are new jobs going to be created? It looks like it. But how long each of these new jobs is going to last? Are we in an environment where you went to college for 4 years and you use the knowledge you learned in those 4 years for the next 20 years in your career? And those days are certainly over.
Cool. So should we move on?
Yeah, so I think you wanted to do a deep dive, right, on some of the aspects.
Yeah, but looking at the time,
Yeah,
maybe
maybe we skip ahead and come back to this
Yes.
if we need to summarize, and we can just look at the case studies.
You can continue, guys. Not an issue with the time. You can continue.
I think
Okay.
what because I think this to some extent the case studies will bring it together. So if you don't mind, Manmohan, we'll go ahead and talk through what an actual implementation of a solution using the language models looks like across like 2-3 years, and then we can go back to deep dive into any of this ones.
Yeah, sure. Yeah. The
Harshada,
way
is that
you want to continue, you can.
yeah.
Let's do that.
Sure. So the first case that we're talking about is, something where we had done to kind of assign sentiment to flag high risk calls from some call center transcripts that we were looking at. Now, this project was done in 2018, which doesn't seem like a very long time ago, but in the context of, I think, language models and where AI for language models is going, it's a lifetime ago. So like I said, the use case was that we had some call transcript data. This was automatically created call transcript data, I think from some Zoom calls. There were also some video calls. And we had to take this transcript data and flag which calls were high risk from a customer satisfaction standpoint. Essentially, what we did was we looked through the transcript data, did some named entity recognition, topic identification and keyword recognition, Python, some custom code that we wrote, as well as using some existing libraries that Python had, was the primary work that we did. Our notes on the experience, our solution had to have a custom dictionary that we needed to create for keyword and tone, because it was a fairly specific area and our sample sizes were also small. So it wasn't like some generic, I'm calling to complain about the quality of soap or shampoo that I have bought. This was a B2B context. So many of the readily available dictionaries or sentiment classification models did not have the vocabulary that was needed for the data that we were seeing. Right? The diarization in our input data was actually quite inaccurate. So the speaker attribution, especially if there was overlap in speech between two speakers, it did a very, very poor job of saying who was talking, which meant therefore that sometimes the dialogues that were said by the customer was being attributed to the agent. And then of course, your ability to flag which is a high risk call and what is the sentiment expressed by each person is immediately affected. This was also data which had both customers from India. It also had some customers from Europe. So the non-English input was transcribed in English, and this affected the performance of the models because, again, vocabulary became an issue. And ultimately, we had to have a human-in-loop solution to test whether the detected sentiment or keyword score was actionable or not, which is not ideal for a business to extract value from a solution like this, right? So, and I can safely say that if this project or this kind of data comes back again, and we have worked on similar data sets since then, the choice of solution as well as what you'll end up with as an output will be quite different. Right? So I'll pause here. Any questions before we look at the next?
So also at that point, we were thinking of training our own models. Now there is a variety of models available, and even the thought that you need to have your own model, first we look at what is available, whether it works, can I adapt it to my situation versus building something own. That's what comes to our mind. Yeah, Shrihan.
Sorry. Yeah.
No,
So
no.
basically, Harshada, I have a question here. So, like I have faced some challenges recently. Like we are actually, understanding the intent of the customer emails, and we are actually like building a model and extracting some of the data from those emails basically. So while doing so, what challenge we faced is like the client was very like reluctant to share their data, which is very client sensitive, like the PII information and all these things are there. So building a like a vast amount of production like emails, it was quite challenging for us. So like, have you faced similar things like like, and how you like resolve those things?
Hmm. Gayatri, you want to take this?
So this is an interesting question. I think data sufficiency in order to be able to train a model, right, is definitely an issue. Sometimes you feel like you are basically dying of thirst in the middle of an ocean because there is so much data, and yet for the context that you want, right? Either because the client says it's sensitive data, I can't share it, or because it's specific to a very small domain, you are not sitting on enough data to actually build a model or to do anything useful with it. One solution seems to be to generate synthetic data, like you had mentioned, Manmohan, but that comes with its own um, challenges because is your synthetic data really representative? What are the ethical considerations around using it? Those are questions that come up and still don't have any real answers. I think we have seen examples of synthetic data being used or generated in order to do this data, and this idea is not new. It used to be called bootstrapping in the past, where if you didn't have enough sample size of a particular class of behavior, you would essentially regenerate or oversample for that to be able to get the kind of pattern recognition that you wanted to see in your model. So there's no easy answer out there because the challenges, I think, all of us who work in this space continue to see them, but the solutions we find, there is no one size fits all. It does need to be specific to a client. Are we going to choose with, go with asking them to mask data, or say that, we can give them an algorithm which essentially will mask the data at point of extraction and you give us just the mask data? Or
That's possible. Yeah, that's
kind of thing is possible, right? That you run the algorithm, you mask what you think is sensitive information, and then share the rest of it with us. That could be a answer.
Yeah.
Augmenting with synthetic data or similar data from other clients or from similarly masked or web or public sources of information can be another way of doing it. Third
So-
could be choice of technique itself, right? That you, instead of choosing a model that requires a large sample size, and with language models, that does tend to be a problem. You do need larger sample sizes for statistical methods to work. There, if you go with more of a rule-based approach, that will still give you the kind of return you're looking for. So the answer, there's no one-size-fits-all answer, but certainly you have to break it down to see which one will work for the client context that you are working.
Yeah, right. So yeah, like we are also like like we have built some synthetic data like automated data generation and all, but kind of again we face some challenges. Like actually we had to like extract some policy numbers, and even those policy numbers, if they are masked, like we don't know the type of the policy, because in that policy number only certain alphabets will tell that what kind of policy those are.
Yes.
So yeah, like we face certain challenges on that.
Yeah.
Correct.
And
So-
the specific challenges, right? Or is there anything else, any other value which is correlated to policy type? Value of premium, for example. Can I build a rule around value of premium and agent who is issuing this, like some combination, to be able to say, okay, these are all life policies, these are all health insurance policies. So the kind of, and so that's where the answer is not generic, right? It has to be very, very specific to the context of the client and the data that we are working on.
Right. So two more points, Munmun, not from an experience perspective, but more from an academic discussion that I have had with some of the people I got connected while working. So there is the zero shot models that people are working on. And if your context or problem is more classification related, right, there could be zero shot model or small shot models that you could implement in your solution. So
Yeah,
that,
right.
yeah,
Yeah.
so, that could be one.
Got it. Yeah.
So
Maybe I think as we talk through the cases which are more recent, because
Hmm.
the one we just discussed is quite
Right.
simplistic in the way that it approached the entire thing. Harshada, you want to talk about this one?
Right. So I did mention law analytics while we were speaking on other slides, and we wanted to present this case more as something which is evolving. So the idea was that judgments and law space itself is starting to adapt to a lot of data science, data analytics kind of solutions, and there are a lot of judgments that get posted every day on all the court sites, including Supreme Court, High Court, District Court. So what we had decided, or the product that is getting built, we wanted to do was extract these judgments, summarize it, and obviously the summary is something which would still run into 3 pages, convert it into audio, and then this can be read or sorry, heard by people as they are on the move, figure out whether it relates to the case that they are working on, and then do the needful, so helps in research, etc. So the first part of it was getting the data, and nowadays it's simple but hard, and I'll explain why I'm saying it's simple and hard, because these judgments get posted on the website almost every day. So there are about 5, 6 judgments posted on Supreme Court site every day. You see it, you can download it. But there are challenges when you want to automate this process. So obviously they'll put a lot of cache, they'll put firewall for the download to happen. In technical language, if I build a cron job today, I'm not sure whether it's going to work tomorrow. So human has to be on loop. There should be somebody who checks that there are 5 cases on the site, and 5 are what I have got in my data. The second thing is basically using the data from PDF. So this piece has also evolved. When we started, data had to be in a format that is easy to read in a structured methodology. You should be able to write an SQL and extract the elements that you needed. Versus now, there are a lot of libraries in Python where you can read PDF data, OCR data, all of that. So this works great now. Then you come to summarization of text. So when the text is generic, like a news item that you would have on a usual newspaper or a site, when in these cases where it's generic data, summarization is easy. I just have to figure out which model works best for summarization one time, uh, load it out, and you will get a good summary, versus domain specific summary. So if I may, law in terms of language itself is very different from the usual English that we speak. Therefore, it has to have a way of summarizing. It has to learn from a domain expert. There are a lot of frameworks that you need to build in, saying, when I create a summary from a document like this, I should have who's the responder, who's the judge, how do I identify the judge, what are the outcomes, what were the facts that were stated, what was the evidence that is presented. Therefore, you need to have a good framework which is domain specific to get a good summary out of it. Obviously, also the fact that there are 2 types of summarization, and we can link it with how we make notes. So either I make notes in a book just by underlining what is written and is important. So that is extractive, right? I'm just picking up certain sentences and saying that, this is my summary. Whatever I have highlighted is my summary. Versus I read a book and then say, keep it aside, think about it, and write my own summary, which is a more human way of figuring out what linked or what clicked with you, and writing a summary. That is called abstractive summary. And obviously, when you want to hear a summary or read a smaller part of the text, it has to be engaging and story-like. So, which way of summarization to do is the other piece. And since it's a long text, maybe for some section, abstractive summary will work better, extractive summary will work better for other sections. So, you have to do a lot of experiments there. So thing is that you have the components ready, a lot of components ready, but you still need to have a good design of experiment plan out there to say that for this context, this is how it's going to work. So for extracting element A, I'm going to use this model. It is going to give me this text and I'm going to represent it likewise. So I think I made that clear. Also, like I said, components. So text to speech, a lot of components available even in simple plain Python libraries. And when we did this, we used one specific to change our text to speech, which worked pretty fine. In fact, it gave a good rendition in Indian accent, which is what we wanted. So notes on the experience. First of all, testing across libraries is critical. So, like I said, which what component do I want to put in what space? That is what I need to decide. And that is more, I mean, a lot of time art, not just running the code, but understanding the context. Moving on, evolution is quick. So what we did like last month, it is going to change. I will have a new model now. So we by that time Llama hadn't released. But if I had to go back, I would rather pick up Llama and do some of my work using implementing it. Um, so yeah, I mean, also on the text to speech piece, Bhashini was just building, and it's a very strong tool now in the India stack. So if I had to go back, I would have rather used Bhashini to change all my text to speech because it has a better language capability as such. And data acquisition will increasingly become challenging. So a lot of people will get into the space, and more captchas, more firewalls will be put for us to figure out and tackle on. So yeah, I mean, this was a very interesting case or project that we did some time back. But yeah, things evolved so much. So if I had this project again today, a lot of my components are going to change drastically.
And this we're talking about something that is, just about a year old, right? So as you can see, the space is really, really changing. So even for the same thing, I think being aware of what is the next tool out there and how is it, you know, outperforming in your client context is something to regularly test. And of course, there is the open space of where there is nobody who is doing good work in creating, for example, good recognition for a specific language, say for an Odia or for certain for Konkani or Tulu or in many languages which don't have adequate coverage yet. So doing work in building coverage in those spaces can also have a lot of value. So I think this was another case study. So do we want to pause here for any questions on this one?
I think move on.
Yeah.
Yeah, we can go ahead.
So I think it's 5 o'clock. The next case also was, really related to how we're working with text data. Many of the insights that we have are quite similar. That you do need to use domain-specific knowledge. That the solution is not going to be static, and you will also need to evolve to find better models and get user data back into the learning loop. And that experimenting across part of the solution to find which is the library or which is the specific model which will perform best in this context for this sub-objective is really important, and designing the workflow with the best of each of them and designing it also so that it's modularized, so that if you're changing the algorithm that you're using to do the summarization, it doesn't affect the text-to-speech module later. It shouldn't be dependent on each other. So that really is the insight. And I think what we wanted to do was close with, some summary points on where we think this language model space is going. One is building own large language models is not possible without enormous resources. So unless you're like a Microsoft, Amazon, Facebook, building and ownership of those large language models is really not a possibility. Domain-specific language models and use cases are the next frontier, like Harshada was saying. The legal world, for example, uses a very specific type of English, and it has frameworks which help in extracting data in that context, and regular large language models don't perform well in that space. So domain-specific language models and use cases are where work is going on right now. Training data challenges will continue, and I think this is the one thing that has the potential to really upend the entire space, because there are IP issues related to ownership of training data, and the synthetic data question also comes up. At what point is it okay to use? Increasingly, as we run out of fresh data for large language models to train on, synthetic data will get generated, or large language model generated data itself will get used in order to train further large language models as they get built. So at what point does that really become useless and you're running out of fresh insights because you're throwing the same old garbage back into the model? That question is going to come up. And there is a risk of failure as AI solutions become human supervision free. And the cost of that one failure, even if it is one failure out of 10,000, because there's no human being waiting to prevent it, that risk of failure of AI solutions is not actually handled for in the system as a whole. So essentially, work which kind of minimizes that risk, or sits at that edge where it picks up the failure and makes sure it's not really happening. I think that is where we should look for areas of potential for us to find more work and for us to evolve in the work that we are doing. So that's really all we had to say. Any other questions or final comments?
I again have a question. So basically, again, I faced some challenges with the AI detector. So I have seen that lots of researchers or academicians and the people who are managing contents, they actually have to pass through the AI detector, and kind of they're getting caught there that every phrase they are putting, it is kind of AI generated. Even I have tasted with some of my own text, just I like to like kite or something like this. So it is telling that it is AI generated. And even the paraphrases, paraphrases are also not working very fine, because the paraphrased text which is coming, even if you put that in the AI again, they are telling it is AI generated. So I think, it's a very scary situation. Like right now we are going through that.
Absolutely. And this was a case of, someone I know who was on my LinkedIn network who had actually posted. So she works as a technical writer, right? So which means she writes on her own, that's her job. And she said recently her work was flagged for plagiarism and for AI generation because there were no errors. So she downloaded her work, made a few mistakes, and resubmitted it, and it got accepted. So therefore, this risk of failure of AI solutions as it becomes human supervision free, where genuine human work. So, and it is at a cost, right? I mean, your work which you put in, she's paying a price for being too good at her job, if you think about it that way. So I think it's an open problem, and areas which are open problems are where there is potential for a solution that we can offer. So as enough of these cases happen where their genuine work is getting flagged as AI generated, if that is happening, then the use of AI in that space needs to be monitored or modified so that there is no human cost to it anymore. How will that happen? What will the trigger be? What will the commercial application of that be? I think those are questions which I also don't have an answer for. So I'll join you in asking the question, Manu.
Yeah.
But it's something that is true. It is this risk of failure part, and us getting into a kind of recursive loop on using synthetic data to train large language models. All of these things are becoming I think, real problems that we'll have to solve in the near future rather than in the far future.
Yeah, so before we take Jayanta's question, I have one more follow-up questions. And with this context only, on this context, like I have seen that many companies who are, like coming as AI detector or paraphrasers, they are kind of, like not very much, like the kind of, like doing justice to AI. Basically, what they're doing, even it is not AI, it is kind of a scam. So even lots of scam going on in the name of AI. That is what I have found.
Yeah.
Or models where the false positives are very high are implemented. And therefore, so, that risk of failure part is not handled well. Like, what do you do with a false positive? It's actually written by a human, but you are classifying it as something by AI. So the models that they have in place are clearly not good enough, right? Right now, or maybe what they had said was that it's good if it flags 1 in 500. You may be that 1 in 500, right? So ideally, all of us want 0. And we never want to be that one false positive that an AI picks up, because then we're sitting in a world where we don't get help. So I think that really, the scams will get detected, they will get weeded out. Eventually, I think the hype cycle will be over, like Gartner likes to say. But yeah, we are here right now. There's no, we'll have to find the answers together.
Correct. Yeah, Jayanta has a question. I guess he raised the hand.
Okay, ma'am. My question is that is there any chances to in future that the generative AI make another generative AI?
What about
Is there any chances what I've seen from the Robot 2010 movie? Is there any chances?
That we'll hit the singularity? I think there are many famous Nobel Prize winning, some Nobel Prize winners who are saying that we are going to hit the singularity very soon. But I don't know. I'm not anywhere close. Harshada, do you want to contribute and answer this question?
So right now sounds like sci-fi, but a lot of sci-fi has become reality currently. What we thought as sci-fi, say 50 years earlier, is now reality. So you never know.
Okay, ma'am. Got my answer. Thank you, ma'am.
Thanks.
Okay, great. Thanks, everyone.
Thank you, everyone. Had a good time talking to all of you. And thanks
Yeah,
for arranging this.
thanks, Harshada. Thanks, Gayatri, for coming and speaking. Like, we thoroughly enjoyed the session. It was really insightful. So just stay tuned for, more sessions like this coming up. And probably, we will invite you more for more such sessions.
Sure,
So,
be happy.
yeah, thank you so much, everyone.
Okay, thanks. Bye.
Have a good day.
Yeah.